Hello friends, in the previous video we have discussed it till sample space. So now let's continue with the introduction video only. This is part 2 of the video. So in this video let us learn few more things. So what are elementary events and how to find out their probability. Elementary events are nothing but an event having only one outcome in an experiment, then such an event is called elementary event. So first, suppose this is a coin, and when you toss it once, you will get either head or tail. Correct? Either head or tail you will get. So, probability of getting head is, probability of getting head, so once you will get 1 by, how many outcomes it will be? Head is one outcome, tail is one outcome. So, probability of getting head is once. So it becomes total number of outcomes will be 2, no? So the probability will be 1 by 2. In the same case, probability of getting a tail. When you toss a coin, you will get tail once. By total number of outcomes, it will be 2. So for the event H, the probability will be 1 by 2, no? For the event T again, the probability will be 1 by 2. When you see here, there is only one outcome. Okay, the event which has only one outcome, then such an event is called elementary event. Hence these two events are called elementary events. Okay, these two events are called elementary events. Clear? So why did I take here 2? Because there is possibility of getting two outcomes. One is head, other one is tail. So in the total number of outcomes 2, head you can get it one time and tail you can get it one time, because we have assumed that probability is based on assumption that all the outcomes are equally likely. Okay, remember this yellow, nothing but equally likely outcomes. Clear? So now how to find out their probability? Okay, see here, in this example I will show to finding the probability. See, I told you that from this explanation, event H and event T both are elementary events. Let us sum up these two probabilities. Let's see what do we get. 1 by 2 plus 1 by 2 will be getting 1. So from this what can we conclude? Sum of probabilities of elementary events in an experiment equals to 1. This is the conclusion that we need to get from this explanation. Clear? So this is example 1. Let me explain you again with another example. This is example 1. I have taken an example in the previous video that when you have in a bag 3 pens you are having, one is blue, other one is black, third one is red, no? These are the 3 pens are there, and we have an assumption that all the outcomes are equally likely. So when a person is taking a pen randomly from the bag, so probability of getting blue is, so one time you can get, because outcomes are equally likely, no? So when you take the 3 pens at one time each, so total number of possibilities is 3, probability of getting blue is 1. So this is probability of getting blue is 1 by 3. In the same way, probability of getting black is also 1 by 3, because out of the 3 total outcomes, one time you can get black, one time you can get blue, and other one time you will be getting red. Clear? So from these 3, what can we conclude? We can conclude that we have to see whether these are the elementary events or not. So what is the elementary event definition? Nothing but the event which is having one and only one outcome, then such an event is called elementary event. See, let us see in this P of B, in this B event, how many outcomes we got? Only one outcome we got. So that's why here blue, probability of getting blue is a elementary event. In the same way that applies for black also and for red also. So only one outcome is there in the numerator. Only one outcome should be there. Then such an event is called elementary event. So here these 3 are elementary events. So sum of all these elementary events should be equals to 1. So it becomes 3 by 3, 3 ones are 3 ones, so that is equals to 1. Clear? So from this what can we conclude? Sum of probabilities of all elementary events in an experiment should be equals to 1, is equals to 1. So that is the final conclusion we have to draw from this explanation. Clear? This is elementary events and their probability. And let me explain you what are non-elementary events. First, suppose you have this dice, okay, like this. One is 4. So like this we'll be having a dice. Clear? Will be playing snake and ladders. Did you remember that? So when you throw a dice like this, what is the probability of getting 4? Okay, what is the probability of getting 4 and more? So it means greater than or equals to 4. So what are the probability values of getting more than or equals to 4, and what is the probability of getting less than 4? So in a dice, how many faces will be there? 6. Correct? 1, 2, 3. Other one will be 4, 5, 6. So what is the probability of getting greater than or equals to 4? So what can we get? What will be the outcome if it is greater than 4 or equals to 4? Means it can be either 4, it can be either 5, or it can be either 6. Correct? And one more thing. If it is less than 4 means what? It can be either 1, 2, 3. So these are the possible outcomes. Correct? So greater than or equals to 4 means we'll be getting 4, 5, 6. Here we'll be getting 1, 2, 3. So in this case, number of outcomes is not 1. Here also in this case, number of outcomes is not 1. Hence, first suppose when you consider this event as A and this event as B, so probability of getting probability of having greater than or equals to 4 when you consider that event as A, and probability of getting less than 4 when you consider this event as B. When you see here, what does this becomes? Number of outcomes will be 3. So hence it is not 1. Here also number of outcomes is 3. So this is also not 1. Hence number of outcomes are not 1. So these events A and B are called, these two events are called not elementary events. Non-elementary events. Here these two elements are called non-elementary events. And how to find out their probability for this? So number of outcomes you got by, so probability of A is equals to number of outcomes you got by total number of outcomes. So how many phases will be there when you throw a dice? 6 chances will be there. So 3 by 6 for event A. So probability will be 1 by 2, and in this case probability of event B is equals to how many chances will be having? 3 by total number of chances 6. So here also probability for the event B is also 1 by 2. Clear? So for probability A and probability B will be getting total 1 by 2 in each case. Clear? And now in continuation to this, let's see what happens. So what is the event A? Event A is nothing but greater than or equals to 4. See, when you write the outcomes, so this is a sample space. So these are all the possible outcomes, correct? When you write these outcomes greater than or equals to 4, it means from here the outcomes we have to put it under the event A, correct? And less than or less than 4, it means all these outcomes you have to put it under B. Clear? So what will I do here? Probability of event A plus probability of event B. Let's see what do we get. That is equals to probability of event A. What did we get here? It's 1 by 2, and probability of event B is also 1 by 2. So 1 by 2 plus 1 by 2, it is 2 by 2. So you will be getting it as total 1. Correct? And now when you see the events here, A is greater than or equals to 4 and B is less than 4 this. So B can be written as not A. Correct? Because out of the total outcomes, B is this, no? So excluding A means remaining is B only, right? So in the place of B we can write not A. So I am writing probability of A plus probability of not A equals to 1. Same step I am continuing here. Clear? So in the place of not A, what can we put here? It's E bar. A bar, sorry, it is A bar. So probability of A plus A bar equals to 1. We draw this relation from this explanation only. It's just continuation. So from this, what can we say here? It's nothing but this is called a complementary event of A. Clear? This A bar is called a complementary event of A. So therefore from this, what can we say? Probability of A bar is equals to 1 minus probability of A. Hence A and A bar are complementary events. Clear? Did you remember? Complementary angles are sum of two angles is equals to 90 degrees. That is the complementary angles. Here complementary events is nothing but probability of one event plus probability of not of that event is equals to 1. Okay, this is the concept. And now in continuation to this, we have to learn what is meant by impossible event and what is certain event. So let's move on to that now. See here, impossible event and certain event. First, suppose when you throw a dice like this, what are the chances you'll be getting outcomes? It can be the 1, 2, 3, 4, 5, 6. These are all the possible outcomes when you throw a dice. First, suppose if they ask you what is the probability of getting outcome as 7. So, if suppose they will ask probability of, let me think that event as G, probability of getting outcome 7. Outcome 7. So that event is getting outcome as 7. So probability of getting 7, that is P of E equals to. When you see here, what are the outcomes you'll be getting till 6 only. So from this, is there any probability of getting outcome as 7? No. So probability of getting outcome 7 is 0. So this event which has the probability as 0, then such event, E event, is called impossible event. Clear? Is called impossible event. It means the event whose probability is 0, then such an event is called impossible event. Clear? So what is meant by certain event? First, suppose when you take an event F in such a way that it is asking chances of getting outcome as 6 or less. So as 6 or less. So chance of getting outcome as 6 or less. So when you throw a dice, how many outcomes should be having? 1, 2, 3, 4, 5, 6. So in the event they are asking chance of getting outcome as 6 or less than 6. So how many outcomes you will be having? 6 outcomes. Total number of outcomes is also 6. So probability of getting outcome as 6 or less is number of outcomes is 6 by total number of outcomes is also 6, that is 1. Probability will be 1. So the event whose probability is 1, then such an event is called certain event or a sure event. Clear? So here F is called certain event or sure event whose probability is exactly 1. So from this, what can we conclude? Till now we have dealt with everything, right? So from this, what can we conclude? That when E is an event, so probability of an event can be either 0 or it can be 1. So these probabilities will exist in between 0 to 1. So from all this explanation from video 1 and video 2, from this is the conclusion we can draw. Clear? So based on this explanation, we are going to solve the problems in exercise 13.1. Clear? So this is the probability expressed in terms of numerical measure. And now one more concept is there, that is a deck of chords and their probability. So what is that? It's a deck of chords and probability. So I do have a theoretical knowledge in this, no practical knowledge. So let me explain whatever was told to you in textbook. Okay, so here a deck of playing cards consists of 52. So total number of cards will be 52, out of which total number of cards is 52, out of which it is having 4 suits. 4 suits in the sense equally 13, 13, 13, 13 and 13. 4 suits are there, and each suit is of named called, one is black spades and the other one is black clubs, third one is red hearts, red diamonds. Okay, so in each suit you'll be having one ace, here also one ace, and after that you'll be having the cards numbering from 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, after that you'll be having one king, one jack, one queen. Okay, in the same way you'll be having for all the 4: spades, clubs, hearts, diamonds. Okay, so same thing for 4, 5, 6, 7, 8, 9, 10, king, jack, queen. Here also 2, 3, 4, 5, 6, 7, 8, 9, 10, king, jack, queen. 2, 3, 4, 5, 6, 7, 8, 9, 10, king, jack, queen. So let us count 3, 6, 9, 10, 11, 12, 13. So total number of cards will be 52 cards. It is divided into 4 suits. So black spades, clubs, hearts, diamonds. Okay, so the first 2 are black and the last 2 hearts and diamonds are red. So this is the concept you have to remember. So based on this we'll be having the problems also. Okay, let me give you an example for this deck of cards now. So this is the example which I have directly taken from your textbook only. So one card is drawn from a well shuffled deck of 52 cards. I told you that total number of cards will be 52. So one card is drawn. Calculate probability that the card will be an ace. Okay, when you see here, out of total 52 cards they are telling, they are not asking about particular suit. Out of the total 52 cards, so how many aces are there? In each suit there is an ace. It means totally there are 4 aces. So probability of getting an ace, I am denoting the event as E. So probability here, let's write it in the solution. Let E be an event having ace. Okay, so probability of getting an event will be total number of outcomes will be what it is. Total number of cards is here 52. Why 52 is taken? Because here they told that one card is drawn from a well shuffled deck of 52 cards. So out of the total 52 cards, how many aces are there? Only 4 aces. So from this we can write that probability of getting an event having an ace is 1 by 13. In the same way they told that not be an ace. So this is same concept, you can apply that here. Before we discuss this complementary events, did you remember? So not be an ace is nothing but can be denoted by probability of getting E bar. Correct? See, this is exactly complementary to the event E. So probability of E bar is nothing but 1 minus probability of E. So 1 minus 1 by 13. So you'll be getting the answer as 12 by 13. So this is the using the concept of deck of cards and finding out their probabilities. Clear? So with this concept video is done. I have explained the introduction into two videos, part 1 and part 2. I think the explanation is very clear. So whatever was given in your textbook and whatever related to the exercises coming now, so I have explained each and every concept. In case you like this explanation, please share it to your friends, and don't forget to like, share, comment, and subscribe to this channel. Thank you.